Hi, everyone. Thank you for joining us to the first MES monthly meeting. We're very excited to be hosting these. Just a few notes. The MES monthly meetings, or just M3, will be taking place every month. The first month will have a tutorial, just as we do today with PUDL. Second month will be early career researchers, and third month will be expert panels. And we'll repeat that every 3 months. Um, Quickly, if you're not already an MES member, please join us via this QR code or via this tiny URL. It should also be in the chat. If you have any submissions for the newsletter, we'd love to hear from you. Please do submit them for the newsletter via this QR code or via this link over here. And if you want to present in the early career research seminar, feel free to scan in over here. And lastly, if you have any suggestions or ideas for what you want to see in the M3 topics, feel free to just let us know on these over here. All right, now handing it over to the PUDL folks.
Great. Okay, so I'm going to go over today like a brief intro of what Catalyst is and what PUDL is. I'm going to do a bit of a deep dive into 4 of our core data sets. And I'm going to go into like what is included in those data sets, as well as how it's collected and some of the irregularities and quirks of using those data sets, with the hope of getting you a little bit of an understanding about how to approach a new data set, whether or not it's these or other data sets that you find out in the wild. I'm going to talk a little bit about linkages between data sets to like web the information together. And then I'm going to do a bit of a whirlwind review over the rest of the PUDL data sets. And then I'm going to try to spend a bulk of the time talking through how you can access PUDL data through our data viewer and through a few of the means of like programmatic access. And generally speaking, yeah, I put the slides in chat. You're welcome to follow along. There's a bunch of links embedded in them, and I'm going to skip over a chunk of this, some of the slides. But if you want to go back and reference them, you're welcome to. And at the end, towards the end, I'm going to just open up some of our data tables in a Jupyter notebook. I'm not going to go over like how to spin up a Jupyter notebook, but it's really just a demo of how you can look at a table in a slightly more interactive way. And please ask questions as they come up. I'm going to try to save some time at the end for questions, but definitely feel free to ask questions as they come up. So please just like raise your hand or ask them in chat. Now that I know how to find the chat, which is good. Great. Okay, I'm gonna jump along. So Catalyst Cooperative is we're a worker-owned cooperative. So there are 8 worker owners, and we are mostly data engineers and analysts. Generally speaking, our mission is to try to support folks getting access to the data they need so that they can ask interesting questions about the energy system. And we are the like original creators and maintainers of PUDL. If anyone can like emoji react or put in chat, has anybody used PUDL before or heard of PUDL? I have. Great, we have some yeses. Is anybody like never heard of it before and this is your first time, which is great. That's exciting either way. So I hope that this talk will be helpful for folks who have both used PUDL and never used it before. But I'm sure that based on the like work that y'all are up to, have had trouble accessing data to do your work, to ask interesting questions, and like have spent a lot of time like toiling through the initial process of finding data that you needed for your research, getting it into the right shape, cleaning it up, getting it connected with other information that you need to ask your questions, and like then asking your questions and finding out that there's like quirks and annoyances within the data that you only found out later. And that all of those like struggles and frustrations is why we started Catalyst and why we started making PUDL, because we knew that a lot of folks were struggling through that initial step of prepping the data to get it to the place that you actually need. So over the years, we've been working on and developing PUDL for almost, I guess, 9 years now, which is wild. And we've supported a wide range of folks accessing information. And yeah, okay. These are a handful of the like core data sets that PUDL has been processing. And so we pull mostly public data, mostly data about the US, or actually this is all data about the US. It's mostly about the electricity system, but some of it is about the natural gas system and other pieces of the energy system. Um, I'm going to go into depth into these four data sets that I have highlighted. They are mostly about power plants, and then we'll talk a little bit about the other data sets that we have pulled in over the years. Um, Great. And again, please put in chat if you have any questions or raise your hand. So I'm going to talk about EIA 860 and 923 together because they are really companions. They're peanut butter and jelly. 860 is the annual electric power industry report, and 923 is the power plant operations report. They're both published by EIA, which is the Energy Information Administration, and as its name implies, it's an information administration. They're in the business of providing information. They publish and process over 50 forms. PUDL like pulls in and cleans up and republishes like about 7 of them, but EIA has like a lot of information about the energy systems, which is very helpful. They're an arm of the Department of Energy. But yeah, their main mission is sharing information, which really shows in how they attempt to make their data accessible. 860 and its companion 860M, it mostly has information about the attributes of all of the generators and plants and boilers across the US. So any generator that's over 1 MWh needs to fill out 860M or 860, and it has information mostly about the characteristics of the plant. So it's like how big it is, its operational status, a bunch of important dates in the plant's life, and things like prime movers, technology descriptions, and emissions control equipment. Conversely, 923 is the operations of those same plants. So it's the throughputs of the plant, things like net generation, fuel deliveries, stockpiles, and fuel consumption. And it's very similar plants that have to fill that out. Here are some like key attributes of 860M, but I'm going to brush over these slides, but generally it's been reported since 1990, so it has a very long time series, and most of 860 and 860M data is annual. 860M is its like monthly updates. It's the freshest, I suppose, place that you can get information about like proposed, whether or not new generators are proposed or new retirements are scheduled. And similar, 923 is very similar. It comes out annually with some rolling monthly submissions. There is a lot of data in 923, which is monthly, like it has monthly net generation and monthly fuel deliveries, et cetera, et cetera. 923 and 860, and really a lot of the EIA forms are the data is collected by EIA, sending out these like kind of locked down spreadsheets with a bunch of data validation embedded in the spreadsheets. And they do things like set lists of codes and like curate list of codes like energy source codes or fuel types. And as a plant operator that needs to fill this information out, you can only select from a drop-down menu of options. And also the operators get pre-filled out forms with the IDs and codes of their plants filled out. So when EIA gets these forms back, they do a fair amount of data validation before they publish the information to the public. So they do a decent job of collecting and curating their data. There is still some inconsistencies and challenges and frustrations with using EIA data. The main one really is that for very good reason, for like general accessibility, EIA publishes usually a lot of their data in annual time slots of like, a collection of spreadsheets. And those spreadsheets have changed over time since the 90s, since I started publishing this, which means that stitching together a lot of like a longer time series of data is a little bit challenging up front. And they can sometimes change where the headers move or headers are and just the column names and that kind of stuff. So it can be a little bit challenging to just like prep everything for a long time series. Um, some other frustrations of using EIA data include there's often some redacted data. They do a decent job of documenting their redactions, but they're kind of they have a lot of documentation, so it's easy to miss up front. And there's also the EIA does an excellent job of creating IDs and codes for all of their plants and generators and such. And they do publish some associations of like the units that make up a generating unit, but they're not always complete associations, and they don't have full coverage of all of the plants, which can be annoying upfront to use. And also, not all of the data mostly in 923 is reported at the most granular level. So for instance, there's a net generation table that reports net generation at the generator level, which is great. That's like super as small as you can get, really. But only like less than half of the generators actually report their net generation at that level. Like the rest of it is published at a higher level of aggregation, which is just can be frustrating as a user if you want a really granular data. There's a ton of different applications of things that folks use EIA to like examine and understand. I'm not going to get into them, but there's example access links as well as example applications that you're welcome to explore after the fact. Before I move into the other data sets, does anyone have any questions about 923 or 860? Please stop me if you have any questions that come up by all means. Great. Okay, I'm going to move into FERC, which is FERC Form 1, which is the Electric Utility Annual Report. This is honestly one of my favorite data sets, but it is also quite messy, so it's easy to love, easy to hate. FERC is the Federal Energy Regulatory Commission. It's also an arm of the Department of Energy. But FERC is a regulatory agency, so their primary like goal and mission is to set rates and regulations and issue permits. And they do most of their work through quasi-judicial proceedings, and they kind of happen to collect a lot of data that they occasionally use in those quasi-judicial proceedings. And that should give you a little flag or warning that like some of their data is not as clean as one would like it to be. FERC Form 1 in particular is a comprehensive overview of both financial and operating report for major electric utilities. So this does not have complete coverage of US utilities, but it is a lot of the large ones. And it is pretty sprawling. It has over 70 tables. It has a ton of information about power plants. I will highlight that the information that is kind of reported nowhere else is the capital costs of power plants, both the like upfront costs of plants as well as the like ongoing trickle of money that they pour into plants over time. There's also a ton of tables about accounting, so a lot of the utilities' assets and liabilities and how they make their money, what things they put into rate base, for instance. So it's a lot of information about like financially how utilities tick, and what they're up to and what they're pouring money into, which is quite valuable. Similarly, this has been reported since the 1990s, and it is most of the data in FERC Form 1 is annual data, although some of it is quarterly. Unlike EIA, the FERC Form 1 doesn't have as much data validation or restrictions put on it upfront, which leads to a lot of frustrations, which I'll go over briefly. But before I get into like the data itself, one of the main inconsistencies or frustrations of using Form 1 data is the format in which it is published. So from 1994 all the way up until 2020, it was published as a DBF database file, which is a super archaic data format that hasn't been supported for quite some time. And then in 2021, they converted and started publishing data as XBRL files, which is the extensible business reporting language, which is much more modern and has like more tooling and validation capabilities, but it's not like a sort of super run-of-the-mill data tool that a lot of folks like learn or use. So just format wise, it's just like a little bit inaccessible in that way. Because of that, unlike a lot of the other data that we just like we archive raw versions and then publish as like transformed and cleaned PUDL tables. FERC Form 1 and a lot of the other FERC data sets we convert into SQLite databases so that you can access the full raw data, but in a more familiar data format. The data itself can be obviously like quite interesting, but there's a ton of free-form text fields across the data set. That's like most of what the data fields are. And that leads to a lot of misspellings and lots of like weird entries from utilities, unlike where EIA restricts the types of things like the fuel source codes and type of plant. FERC doesn't provide that kind of both documentation or restrictions. So, someone at the utility is typing in each year what kind of plant these are, which leads to a bunch of fun mess on the other side. So there's lots of nulls across data set that are not particularly well explained, and a bunch of other kind of individual data errors that are hard to navigate. Also, unlike EIA, there's generally a lack of identifying like IDs or keys across the data set. FERC reports their respondent ID, so the utilities. That's basically the only ID that is published in FERC Form 1, which is kind of bonkers. We end up adding a bunch of IDs for both the plants and subplants, but so you can link data across time and also across tables. So like this Asheville CC plant is published by Duke in 2023, and in 2020 it just publishes Asheville with similar attributes. So you can, as a human, look at it and see. But if you're trying to do analysis over even over one utility across many years, or over certainly over lots of utilities across the full FERC time scale, without a lot of upfront work, it's hard to use the data and link information across time and even across tables within the same year. There are also a lot of nested totals and subtotals across Form 1 data, which especially in the accounting tables, but that shows up in a lot of the other tables, that it in some ways makes the data easier to read if you're looking at 1 year of 1 year of data for a particular utility. You can like look at it and say like, okay, that's the total utility plant in service. That's great-ish. But as a data practitioner and you're trying to analyze a broad swath of data, it makes it hard to know if you are, you can't sum this column because you'll get a bunch of duplicate data in a bunch of different directions. Luckily, when FERC converted to XBRL format, they added a bunch of metadata, and which included the relationships between fields, which let us do more analysis and labeling of and like picking out only the most granular pieces of information in some of these counting tables. And I'll just show you one of the graphs, which is just mostly here just to show you like these tables are quite nested and like quite interrelated. So it takes a little bit of time when you first get to some of these FERC tables to make sure that if you're doing a broad analysis, you have you're not choosing the wrong slices of the data in order to do your work. There are honestly many more challenges in using the FERC data, but and I won't get into today, but certainly FERC is one of the like harder data sets to work with, just like data quality wise. But there is, they do report data and information that is reported nowhere else. So we try to make an effort to clean it up as best we can. And there's a bunch of things that folks do with FERC data, most that I'm not going to jump into today, but have links if you want to look at it later. And some links for accessing FERC data. And I will note that if you're trying to look through FERC, like the raw forms or a PDF version of the form, they all have schedule numbers, and we put the schedule numbers in all of the PUDL tables, and also the like raw FERC tables have the schedule numbers in them. So it's a good way to like reference the tables themselves. Any FERC questions before I move into EPA data? Great. Also, we're gonna at the end or towards the end, we're gonna go over we're gonna like explore some of the tables in the data viewer. So we're gonna be able to like look at the PUDL table. So if anyone if there's like, oh, I would love to go look at that accounting table or poke around at some transmission data or whatever, we can explore it that way. So just keep that in the back of your mind. Great. Okay. The next data set I can go over quickly is EPA SEMS, the Continuous Emissions Monitoring System. The EPA is the Environmental Protection Agency, which is a standalone entity, which is both interprets statutes to make its own regulation and also enforces that regulation. So they're both a regulatory agency as well as an enforcement agency. And SEMS is a byproduct of enforcing the Clean Air Act. So SEMS publishes data. SEMS has data about emissions of SOx, NOx, and CO2. And every plant every fossil combustion unit over 25 megawatts has to have a SEMS unit in it and report data to EPA to make sure that they are in compliance with the Clean Air Act. And they have been reporting data in this SEMS format since 1995. And it is reported hourly because that is what the statute requires. And it is reported at the smokestack level, which is, makes the data kind of interesting in a few ways, which we'll get into in a minute. So SEMS data, unlike EIA data and FERC data, which is like hand entered by folks at a plant or at a utility, EPA sends out these little units that they have designed and built and installs them in smokestacks, and then they are real time collecting data that is like translated and QA/QC'd and monitored in basically in real time from the EPA. So as you can imagine, the quality of this data is quite different than the other data, which is like hand entered by respondents. There are some inconsistencies and challenges with the data. There's occasionally there is like missing and redacted data, but generally speaking, the hard part of using SEMS data is that it's large. It's hourly smokestack level data for every single smokestack in the US since 1995. And so it's quite you can't open it in a spreadsheet. It's basically it's bigger than that. They also, because of the 25 megawatt size requirement, there's also inconsistent coverage across the US, both in terms of generation and emissions across various regions, which is just it's just a factor of the data and the like requirements itself. And also in terms of linking SEMS data to EIA data, a smokestack isn't the same thing as a generator or generating unit, and that can cause some quirks, but we'll talk about that in a second. There's a ton of different stuff that folks do with SEMS, both in analyzing the like hourly generation for the grid, as well as hourly emissions for the grid, and also as for its primary mission, which is enforcement of the Clean Air Act. And there's a bunch of different ways to access SEMS and the downstream, some downstream tools that rely directly on SEMS. Any questions about SIM?
Yeah, I have a question.
Great.
Is STEM still around, or is there any rumors
That's a
with the
great
current
question.
administration?
SEMS is currently still around. Um, yes. There has been a obviously like enforcement of the Clean Air Act. Like the Clean Air Act is still statute. They haven't changed that, but that yeah, I'm nervous that they're going to stop collecting and publishing SEMS. We shall see what happens in the future.
Okay, thank you.
Yeah, it is currently still up to they all the EPA collects it basically in real time. They compile it and publish it on a quarterly basis. Um, so yeah, great question. Um, Great. We're going to talk briefly about a few of the connections between data sets, which are the data sets that we just referenced mostly. And we're going to talk first about the SEM smokestacks and EIA generating units. So as I noted, it's not always a one-to-one connection between a smokestack and a generating unit. That's just the nature of how these plants are built and designed. Luckily, EPA has been publishing a crosswalk. So like EIA does a great job with IDs. APA honestly also does a great job with IDs. And they, a few years ago, published a crosswalk and open sourced all of their code, which generates that crosswalk. We have been updating that code with new EIA data and EPA data over the last few years. So there is a crosswalk, but I just like in terms of a lot of folks get tripped up when they attempt to merge this data because it's really it's a many to many connection and so yeah, that's just a warning that trips some folks up. But there is that connection, which is excellent. Um, the next connection to talk about is again the same set of physical attributes, which is FERC plants and EIA plants. As I noted before, EIA does a great job with IDs and like they have pretty decently tidy data where they communicate like this is a generator and this is a boiler and this is attributes of generators versus plants versus blah blah blah. And FERC, on the other hand, has most of their tables that that have plants report heterogeneous collections of portions of plants. Sometimes they report whole plants, sometimes it's only one specific technology type, sometimes it's like the prime mover of the plant that they report, sometimes it's just collections of units, which is picking on Duke and Excel of like this is all in the same table, not decently labeled. It's really just the names that communicate how they're attempting to break out these plants. We have done a record linkage of to attempt to figure out which portions of EIA generators are associated with each individual FERC heterogeneous plant record, most of which are whole plants, but a lot of which are much more granular than that. Um, and which is helpful to connect the like operational uh, things like net generation and fuel costs from EIA and all of the characteristics of a plant to the capital costs and other marginal costs of electricity that is reported in FERC. The next connection that I want to mention is from about SEC 10K filers and EIA utilities. So the SEC is the Securities and Exchange Commission, so all publicly traded companies have to file annually to the SEC, and a portion of that filing is a communication of the nested relationships between the parent companies and holding companies and subsidiaries and like the nested relationships between utility entities. Which we have linked to EIA utilities, which is helpful if you're trying to understand a particular utility and all of the types of assets and investments that they actually have in all of the tendrils of their companies. Great. Now that we got through those 4 data sets about plants, we're going to do a bit of a whirlwind through our data source, the rest of our PUDL data sources, or some of the other PUDL data sources. And I'm going to mostly do that through walking through some of our data source documentation pages. I'm doing that largely so that if you ever are like, huh, I wonder if this data source exists in PUDL, or I wonder if there's this table, or want to know about the irregularities of the data sources that I'm not going to go over in as much depth today, you can look at the data source documentation page. It is this link in the file, but it's also just docs.catalyst.coop/PUDL, and it's the data source page. Great. And so this is the basically similar list of data sources that we process and republish in PUDL. I'm not going to go through this list in alphabetical order as it's here. I'm going to try to clump the kind of categories together. So we just talked about a handful of the data sets that are that have a lot of information about power plants and utilities. So I'm going to follow on the utility thread, and we're going to jump into 861, also from EIA. And just a brief overview of what these pages look like, the data source documentation pages. They have a little table at the top, kind of like the key attributes that I went over in the slides. We have a list of PUDL database tables. There are like a gazillion for 861, and links to the data dictionaries, which is like a description of the tables and all of the columns, as well as a link to the data source or the data viewer, which we'll go over in a bit. And oh my God, there's so many 861 tables. These pages often also have a deeper background about the data set itself, additional documentation, what the original data looks like, as well as notable irregularities. Because we often find quirks in the data, or users tell us and communicate quirks of use of the data, and we attempt to compile that information all in one place so it's easier to access. So that is just a quick overview of what these data source pages look like and how to interact with them. I'm going to go to the top of the page and then just actually communicate what's in 861. 861 is a report mostly about utilities and utility programs. It's been reported since 2021, or at least the temporal coverage in these data source pages is the years in which we have integrated data into PUDL. I think that 861 goes back further. It just really changed format before that. So we only integrated it until 2001. But there are a ton of tables in 861. They are largely about utility programs like demand side management and demand response and energy efficiency programs. So a lot of these tables are broken up by year of reporting and utility and customer class. So they communicate things like how many customers are enrolled in energy efficiency programs and what kind of savings do they have from them. And again, I'm going to whirlwind through these data sets. So but please raise your hand or stop me if you have questions. The next set of data, the two data sets that are also companion data sets from different forms, from different agencies, are EIA 930 and FERC 714. They both have information about demand across different balancing authorities. Oh gosh, let me move this thing. 930 has been reported since 2015, and it has hourly demand by balancing authority and sub-balancing authority. And they also have interchange between balancing authorities and net generation by energy source. So it is a pretty granular information about demand. 714. FERC 714 is a very similar data set, but it has been reported since 2006, so it has a longer time series. And it has also hourly demand by planning area. Well, it also, interestingly, in my humble opinion, has both the like real demand that happened on the grid and also these planning areas forecasts of their expected demand. And because it's a long time series of forecasts and actual demand, you can compare how well these planning areas have done forecasting demand. And uh, you all are energy researchers. You probably know that that is a particularly hot button issue right now. And like we have, yeah, TLDR is that they have never done a good job of forecasting demand. Um, but it's obviously particularly weird right now. The next data set that I want to cover quickly is that there's two data sets that have projections of various costs and technology types and into the future, which is the Annual Energy Outlook and NREL's ATB, the Annual Technology Baseline. EIA, both of these two entities, federal agencies, have experts on staff and a bunch of data themselves, and they project various technology costs and attributes into the future. We have integrated only a handful of AEO tables, but AEO has many more tables in its original data source. But yeah, cost projections into the future. ATB um, is a good. Both of these are good baselines of that many modelers use in their work in order to like compare various possible future scenarios. ATB they have been very consistent about publishing data for a long time, and they didn't publish data this past year, to many people's chagrin. And uh, we are hopeful based on some of our communication with some of them that they might start again, but we will, find out in the new year. Um, but yeah, they have projections for the next 25 years into the future about various costs and operational characteristics of a variety of technologies at a variety of like different scenarios. So yeah, like we really hope that they will keep publishing that. We'll find out. Uh, the next data set that we actually very recently pulled in was FERC Form 920, which is the Electric Quarterly Report. And this one I am less familiar with it, but I'm pretty excited about it. Uh, it has bilateral transactions in and like market transactions. So a lot of PPAs are embedded in this. Any of the like interchanges between balancing authorities are embedded in this data. It's a FERC data set, so it's they do have more IDs than FERC Form 1 in this data set, but it is not particularly well curated in terms of its like codes and clarity around what type of transaction exists in there. But yeah, it's a large data set because a lot of the transactions or some of the transactions are sub-hourly, so they communicate a lot of information about prices and yeah, exchanges on the grid. So kind of a treasure trove. We just integrated it relatively recently, and so would love for more folks to use it and tell us what is weird in there and help us clean it up. The next two data sets that I want to mention briefly are two data sets that are published not by any US federal agency, but by private entities, both the Grid Path Resource Adequacy Toolkit data and Vibrant Clean Energy's Resource Adequacy Renewable Energy, or RARE power data set. They are both demand profiles or generation profiles of renewables. So GridPath is only in the Western US. Only for a handful of years, but its capacity factor of renewables, of a variety of renewables for the Western US at the hourly level. And RARE similarly is demand or renewable generation profiles, full US, both wind and solar I believe at the county level, and also hourly. The next two that I want to mention quickly is two data sets about natural gas data. One is EIA Form 176, and one is PEMSHA Natural Gas Annual Report. 176 has data about natural gas pipelines. We have only pulled in a handful of data, a handful of tables from, or two tables from 176. We have, luckily, we actually have an external contributor trying to integrate more of these tables. So I hope that more tables will have more tables soon. But it has, yeah, there's a bunch of information in there. The tables that we pulled in are the disposition. So it's like use demand um, by the distribution companies and broken out by customer and customer type. And PEMSHA's natural gas annual natural gas report is we have a handful of tables that are about the distribution pipelines. So it's like miles of distribution pipeline based on material and size and install decade. And the like amount of leaks that happen on for each distribution company, and that kind of thing. So it's a lot of information about each natural gas distribution company's like physical distribution infrastructure. That is my whirlwind tour of some PUDL data, most of the PUDL data sets. Yeah. There are some example applications of what folks use with 714, and oh, this is a link, but about the rare data set, but you're welcome to navigate that on your own. Great. Okay. Whew. That was a whirlwind. I'm going to talk as I'm going to attempt to pull you all in to ask questions about how we can play with and access some PUDL data. But just a quick overview of how of the various methods of how you can access PUDL data if you so desire. This table is ripped straight from our like core data access page, which is linked above. But generally speaking, we try to push our data out into a variety of formats to both for ease and just like we know that different folks have different like favorite technologies that they use to play with data in different platforms. So we have four main ways that we publish data. One is the data viewer, which I will get into, which we'll actually play with a little bit in a minute. And that's an interactive web platform where you can like see all of the data and filter data and download data as CSVs. And I usually recommend that people go here first, both because it has our full like data dictionaries, so like explanation of what we think is what is in these tables, as well as all of the column descriptions. And also it's like even if you're going to end up using the like S3 whatever as a programmatic method, that's great. But it's nice to start here just to understand initially whether or not PUDL has the data that you're actually looking for before figuring out how to download gigabytes of data. We also have some interactive notebooks that are up on Kaggle, and I think there's like 7 or 8 example notebooks that explore a variety of data sets, and one of which is just like how to programmatically access the cloud storage data. But it also has like exploration of the 714 data and the like difference of demand versus actual like demand projections versus actual, and that kind of thing, and explore some of our like more analysis, like some of the imputations that we've done with some of the data. And the cloud storage data is published we have all of our data being published on Amazon's open data collective or open data page. I forget what it's called exactly, sorry. But so you can download all of the data through S3 for free, which is great. We also have Google Cloud Storage, but it's requester pays, so it's another story. But most of our users eventually end up downloading data through the S3 data. We publish all of our we rebuild our full database nightly and publish the data in those first 3 formats. We also publish like stable versioned data releases, which have we used to do quarterly, now we generally do monthly. So we publish that both to S3 as well as to Zenodo, which has like versioned DOIs of all of the PUDL data, both the like full SQL database, all of the Parquet files, the code that was used to generate that particular data set, as well as the like associations of all of the versioned archives of all of the original data. So like if you, especially if you're doing academic research that you would like to be reproducible, we often tell folks to like use a version of the PUDL data through the Zenodo archives. And we have questions about any of the modes of access before I ask, or we actually do a little bit of a exploration of some PUDL data through the data viewer. Great. Great. Okay. So the data viewer lives, thanks to my lovely colleagues who are here, Dashawn and Catherine, at data.catalyst.coop. Oh gosh, I just navigated away from those slides. Just kidding. This is our data viewer. You can, without logging in, browse all of our data dictionaries and search things, and look at the like schema of all of the tables. If you log in, which is like free to register or whatever, you can preview the tables and export things as CSVs or download full Parquet files. But you can just preview away, or you can look through the documentation before logging in. Does anyone have, out of all of that whirlwind of data that I just went over, does anyone have any particular either data set or particular like question that you're like, is this in PUDL? Like, what transmission data do you have? Or can we look at the 176 data or whatever? Anyone want to explore anything in any? We can actually look at the
Can
tables.
we explore the emission data for specific power plants? Or are you
Yeah.
wanting to focus on EIA?
No, so that's great. Um, let's do it. Uh, Martha, what do you want?
When you're done with this, I had a very specific question about the updating of your demand data sets, but we can do that next.
Great, excellent. Perfect. Cool. And if anyone has any other requests, put them in chat or raise your hand as we can compile them. Great. You want to look at emissions data. If I didn't know that SEMS and the EPA SEMS was the thing that we were going to here, I would probably search emissions. And I am a bad speller, but we got there. So two tables come up. This is yearly emissions control equipment from 860. Out is the like layer of processing that we have. Our core tables are like tidy and normalized, but and our output tables are tables that have been denormalized, so like have things like the plant name merged back into them. Just as a quick aside, I assume that you actually want to look at the emissions, not the emissions control equipment, is my assumption. But first, let's quickly look at the data, like the documentation about this page. This is the SEMS hourly emissions table, which is like one of the most, by far, like most popular tables that people come to PUDL for. And yeah, hourly time series of emissions and plant operations required by statute. And this data source documentation has some like information about the level of processing, the source, and the primary key of the data. So like what makes each data record unique. So it's at the plant ID, emissions unit ID, and operating date. So every single emissions unit, aka smokestack, reports from every plant, reports at every timestamp, which in SEM's case is hourly. And there's some usage warnings and additional detail about the data and some descriptions of the columns that are in the data itself. And we can click the preview button, which will take a cute little second to load. This is a large table. But as it loads, we can look a little bit at some of the column descriptions that are in here. So these are some of the primary keys of the data. So date and time, units. It has plant ID EIA, which is nice because that's the EIA ID. SEMS publishes that along with their emissions data, which is great. But yeah, it has this data, because it's a core table, we don't have like the plant names merged into this data. So in order to say, go look at a particular, if you know the name of a power plant, for instance, like you're not going to be able to find that name here. You would have to go look at the plants table, find the name, and find the ID associated with it, and then filter the data based on that plant ID. So yeah, we do not publish an output version of this data table just because it's so large. It would make the table even larger. This is taking a little bit longer to load than normal, but alas. Yeah, but generally I'll keep going through some of the information that's in these columns, which is the gross load, so the gross megawatt hours for each timestamp, the heat content, so the like fuel energy contained in the fuel burned, the steam load in pounds, so the actual amount of steam that's produced during that timestamp, the SO2 mass, SO2 mass measurement code. So this is like what type of measurement actually took the SO2 measurement, which just changes the consistency of the data a little bit. And similar for both NOx and CO2. Gosh, this is taking longer to load than normal, of course. I might let this load and jump into whose question was it? Martha. You had a question.
Yeah. So I guess my question was both a very specific and very general aspect, which you talked about the updating generally and like the nightly versus stable releases and stuff like that.
Yeah.
I am reading in your demand data from mainly the 930 on from S3.
Yeah.
And for 2025, it says the second half of the year is updated, but I'm only getting through November. Is that user error? Is that it's not out yet? Because I'm assuming you're pulling this maybe from the electric grid monitor since the 93 itself isn't quite out yet.
Yeah.
And so then my second question is like, when would you expect something like that to be updated? How often can I expect those to be updated, etc.?
Yeah, these are great questions. The 930 data, while it is like we generally update the 930 data on a quarterly basis, even though the 930 data from the actual grid monitor site is updated on like almost real time. Like it's quite granular and quick. So we don't update 930 data until once a quarter. That's just like is the resources that we have to update 930 data right now. Usually we do a good job of communicating clearly what the most recent update is of 930 of all of our data sets. So I'm a little bit surprised, but I would love to go look into that for you after the fact and let you know when or what is in there and what we like expect to be in there and how that should be communicated. But generally speaking, like we do a monthly update or a quarterly update of 930, and our quarterly update starts February 1st. So we're about to do another round of quarterly updates. So we will certainly have a new version of 930 in the data set that probably we usually our commitment is to release and then like nightly version of PUDL on the 15th of February and then put it in a stable release on the 20th. So our like quarterly releases start the second month of each quarter, and we aim to get in the nightlies on the 15th and the like stable releases on the 20th. So there will be a new version of 930 pretty soon.
Okay, thanks so much. It's super helpful. I may be missing it on the website, but is there somewhere on the website that says like these are the data sets that are under quarterly, these are the data sets that are under?
That's a great question. We actually we have just recently like compiled that kind of list and are trying to put it up on the website because we have it internally but don't publish it right now.
Okay, thanks so much.
Yeah, of course. I know that the link for this was for an hour, and it's been an hour, and I definitely want to respect everybody's time. I also have a bit more time if anybody wants to hang out, and I can answer questions if folks have them. But if you all have to jump, that's also great. Also surprised that the SEMS data is taking so long to load. I'm gonna go back to the main search page and just load a different table that's smaller, just so you can see what it feels like overall.
Yeah, I kind
And
of
I'll
gave you a hard one with the sense.
well, the data viewer generally only grabs portions of the data regardless. And so usually it doesn't take that long to load. It's probably because I'm sharing and it's taking forever. And you know. But okay. But yeah, this is what it generally looks like. You can like it only shows the first 10,000 records of the table. But communicates this is how many records actually are in this table. You can download the full table as a Parquet file or export portions of the data as a CSV. And you can go through and say, like, I don't care about 2013. I want to care about 2025. Oh, yeah, there's no 2025 data yet. It's 2024. And like, yeah, see the data for in particular plant or utility or whatever you can filter as you so desire. So, yeah, that's a quick look in just like how one can play around with the data viewer. I will quickly note that on the data source pages, if you go to any of the individual tables, so like the same table on our data documentation page, it also has a variety of access methods, which just has little code snippets of how one can access the data from S3. So if you want a quick way to, in a notebook or wherever, grab from via Pandas Polars SQL or by using R. I'm not an R person, so I don't really know what that means in general. But yeah. Does anyone have any more questions or things they want to explore?
I am gonna go ahead and stop the recording. So if people
Great.
want to ask questions off the recording.